am itching to get back on them trails. We're this close. Like next week, I think I'm riding trails with CDS Filler and doing a dual vlog. Hell yeah. Anyways, in the meantime, gonna answer some questions from the mailbag. T-Bone Little T wants to know, what are your opinions on the CRF 250L? 5,000 bucks, brand new and fuel injected, is hard to beat. Yeah, I need to ride a CRF 250L because I get asked about it more than pretty much anything else. And yeah, on paper it seems good. Seems like it might be a little heavy for the power. Yeah, I just, you know, I hope by this time next year I will have had an opportunity to get together with somebody that has one of those and like trade bikes for an hour and do some riding and see what I really think about them. You know, I can't give you a good opinion until I do that. I will say though, go check out AZ Desert Dog. He's one of my favorite moto vloggers, and he rides a CRF 250L, and he seemed to like it quite a bit. Speaking of AZ Desert Dog, I think he had a question. Alright, AZ Desert Dog wants to know if I got any good squirrel recipes. He says, my favorite is fried squirrel brain. Unfortunately, it has a side effect, and I've been running out in traffic. Dang close one today. Can't help it. What is your favorite squirrel recipe? That's 2 questions. Is that legal? I mean, 2 questions? AZ Desert Dog, you're illegal. Toy G asks, why is it that a hamster has 4 feet and doesn't wear suspenders? It's bugged me since 1989. Losing sleep. Dang it, Toy G. Not only did you stump me, but now I can't stop thinking about it. I hadn't slept in like a week. I mean, 4 feet, no suspenders. I don't understand. Let's try one of them tough philosophical questions. Chaotic Detour wants to know, are we alone in the universe? Are we alone in the universe? You mean aliens? Is there other life out there? I don't know why y'all ask me these questions. Like I'm some kind of Carl Sagan dude or something. I don't know anything about astrology, but I'll give it a shot. So, alright, where do we start? Well, let's start with Drake's equation. You know, Drake was one of the first members of SETI, and he has a formula out there. If you hadn't seen, they had put up Drake's equation so people can see what I'm talking about. Yeah, right there. So that basically just says that the chances of us finding life are the rate of star formation times the number of planets that form around those stars times the number of them planets that can have inhabitable environments times the number of them planets that get life times the number of them planets that get intelligent life times the intelligent life that becomes capable of sending out radio waves times the window of time that they actually been sending them. So that'll give us some context there. But, you know, basically, what it comes down to is, you know, like, there's the possibility that it's anywhere, and then there's the challenge of actually proving it. And the possibility it's out there, I think, comes down to space, and the challenge of proving it comes down to space and time. So, like, if you consider Drake's equation, you know, first we have to know, like, how many inhabitable planets are there out there, and we used to think a lot less than we do just recently, because we got the Kepler telescope up there in 2013, and you know, it was designed to look at a certain region of space, and particularly look for red dwarfs, which we can't see from here. And we got the idea now that if you have a planet around a red dwarf and it's tidally locked means that it's always facing the sun, or the same side's always facing the sun, kind of like the moon is to the earth. So if you have that, then it's possible that that could sustain life as we know it. So that's all significant, because that means that basically we don't need to have stars that are just like our sun in order to have planets that can sustain life. There's a much wider range of stars out there that could maybe have planets that sustain life, and bottom line, we're looking at 40 to 60 billion planets possibly that could sustain life. That's 40 to 60 billion with a B planets out there that could sustain life. I'm thinking in 60 billion chances the universe is going to make it happen more than once. That's what I'm thinking. So the next thing we need to talk about is time, because if you think about it, like, how long have we been sending radio waves out into space that some alien might be able to pick up? About 100 years, right? About 100 years. And how long have we been on this planet? 180,000 years is how long humans have been on this planet. Taking us that long, right? And how long have we had life on this planet? Like 4.5 billion years, right? So in the grand scheme of things, we've only been around for a very like a sliver of time, and we've only been sending communications out into space for a fraction of that. And we're not going to be around forever, right? Like, we'll probably take ourselves out in like 10,000, 100,000 years or so. We'll be gone. I mean, that's just the way it is. We got these things on this planet called extinction events. That's what happened to the dinosaurs. And we haven't figured out how to get rid of them. And we've added more, like nuclear warheads and super diseases and boy bands. So sooner or later, something will take out life on this planet. And our window of time to communicate will be over. So you got to figure, if there is aliens out there, they got that same problem, right? They got a small window of time also, and you know, it's kind of like two trains passing in the night. You know, well, they'll probably come and go before we can get out there, or vice versa. So the next thing we need to consider is space. Like, just how far away are we from everything? I mean, the 60 billion chances, you know, why don't we get out there and see a couple of them, you know? Like, it's, you know, even if they came and went, if we could go to another planet and find the ruins of life, or we could find life developing, then that would answer a lot of questions. Alright, well, the problem is we can't really get to any of them planets. There's 60 billion out there, but, you know, guess how many are within 50 light years of us? 50 light years. Yeah, about 10. There's about 10 planets that are within 50 light years that we could actually get to and see if there has ever been, or maybe going to be, intelligent life on it. Now, there's other parts of the universe that are way more dense, and we wouldn't have this problem if we were there. But we're out here in, like, the middle of nowhere. So let's talk about getting to a planet that's within 50 light years of us. You know, could we possibly do that? Go out there and see if there has ever been life, or maybe going to be intelligent life on some other planet that's a little bit more in our galactical backyard. So first you might be thinking, well, let's just send like a Mars rover out to one of them planets. It's you know, it'll take it 50 years, but once it's there, then you know, we're good. And like, well, we don't quite have the technology for that, because our Mars rovers, we actually have like a command and response system for them. So we send very, very specific commands up to them to do very, very specific things, and then they send all the information back to us, and then we send more commands to them, and then they send more information back to us. And we can't do that with a 50 light year latency. So probably, like, the fastest way to get this problem solved is to get a person out there. So now you're thinking, okay, well, 50 light years, you know, we could probably get a person out there in you know, 50 light years, and you know, they just wouldn't be able to come back. Yeah, see, the problem is we can't actually go the speed of light. And I don't mean like we can't like build an engine that can accelerate us to the speed of light, because you know, maybe we could do that. Maybe with ion propulsion or something, we could figure something out. But like, there's a problem whenever you start going too fast in space. And it's called hydrogen. There's more hydrogen than there is anything else. And even though it's not that dense in space, if you're going fast enough, you're going to start slamming into some hydrogen molecules. And you're going to start slamming other hydrogen molecules into those hydrogen molecules. And you know what happens when you slam hydrogen molecules together too fast? Yeah, you get a radioactive problem. So interstellar hydrogen really stops us from going more than about half the speed of light. You know, and even if we're in something shielding us from it, doesn't do us any good. That just means that we're now flying through space in an oven, and we become turkeys. So we're only going half the speed of light. Now, I know what you're thinking. I can already hear it. You're saying, hey man, if you're going the speed of light, then your observation of time is going to be much slower, right? Like if you're going the speed of light and you go 50 light years away or 100 light years away at the speed of light, it's only going to seem like a couple of minutes to you, right? Yeah, that's true. That's why it's important to acknowledge that we can't go the speed of light. We only go half the speed of light. And now you're probably saying, okay, well, that's still pretty dang fast. We're probably still not going to age a whole bunch going half the speed of light, are we? Yeah, I think we will. There's actually a formula for that. It's called the time dilation formula. And I can't remember what it was. I've only seen it once in a movie. But if I could think of it, I could probably tell you what the... Okay, I got it. I remember what it is. It's T equals, and time is T. So time equals time observed divided by the square root of 1 minus velocity squared divided by the speed of light squared. Is that right? Yeah, I think that's right. Okay. So given that, let's say let's say we're going to go there and back 100 years. How much are you going to actually age Earth time in 100 years? So let's say it's 100 divided by 1 minus what's half the speed of light? It's 150,000 kilometers squared. Square that. Carry the 1 divided by the speed of light squared. 1 minus that, square root. Alright, 87 years. So, in 100 years, going half the speed of light, you'd age 87 years. That doesn't really give us enough help to solve this problem. So, bottom line, because of the laws of physics and the laws of biology, we're just not going to see anything else but this planet. I mean, sorry, there's probably other stuff out there, but we had the luck of being in a part of the universe where there's just nothing around us, and we're just not really ever going to be able to prove whether or not there is other life in the universe. Basically, we are a planet full of hermits. There you go. All right. Y'all have a good week. Over and out.